All right, so we have this equation here, and the question reads, the reaction mixture represented above is at equilibrium at 298 Kelvin. This 298 Kelvin is going to be just one of your ideal gas temperatures, ideal gas temperature, and it's just one of the standard temperatures you'll see eventually. It says the value of the equilibrium constant for this reaction is 16 at 298 Kelvin. Once again, that Kelvin is going to be the standard temperature in this equation. It just tells us today that we're going to be solving using classroom method. So it's just going to be um, method. It's just going to be the regular way you know how to solve this. No other trick questions or anything. All right. So if Rg, Xg, and Zg each have an equilibrium concentration of 2 molars, that's an important number to note, what is the equilibrium concentration for Tg? All right, we're looking for T. Every time we hear equilibrium concentration, we know that we are looking to solve. All right, and we take a look at our equation and we see that we're given all three of these as 2 molars and we're looking for T. In this scenario, we're going to have to set up an equilibrium expression. All right, and we're solving for the equilibrium concentration. I'm just going to call that K. We'll call it K for constant today. Okay, so we're going to set this up. The equilibrium concentration, the K we're solving for, is going to be very simple. It's going to be the concentration of the products over the concentration of the reactants. All right, and so bringing that over, we know that we have X, so we're going to call Xg. So we're going to call that concentration of X, and since we have a 2 in front of the X, that goes as the exponent. I'm sure you remember. Same for Z, we're going to do concentration of Z, but that doesn't have any numbers, so that just stays as a 1. You can write that 1 there, or you can choose to ignore it. Same deal. Now the reactants, we have R, so we have concentration, it's a bad bracket, concentration of R, no exponent, remember, that means just 1, and then the concentration of T, that is going to be to the squared. All right. Perfect. And now we know that this K is going to be 16. It gives us this number at the start. So we are going to solve setting this equal to 16. All right. So we know that R, X, and Z, as stated here in the problem, are both going, or all three of them are going to be 2 molars. All right. So we get this 2 molar value and we plug it in. 2 squared. Z is also 2. We have R as 2 also, and T squared. Alrighty. So 2 times 2, or 2 squared, which is basically 2 times 2, is 4. 4 times 2 is 8 on top. 2 times t squared is going to be 2t squared. Just put that there. And then this equals 16, as we stated there. It's going to be simple algebraic math there. Cancel and solidify t as our variable. We have 2 on the bottom. We're going to multiply. And that'll be 8 over t squared, that's a bad squared, equals 32. All right, and this is going to be 32t squared equals 8. All right, perfect. And then we're just going to solve for t squared from there. So 8 divided by 32 is going to be 0.25. So we're just going to bring this down since we don't have space. Let's just move it over here. So 0.25, remember we divided 8 by 32 equals t squared, all right? And when you square this, we need to cancel it. So we do the square root of it. The square root of 0.25 is going to be 0.5. So T equals 0.5 molar in concentration. And that is going to be your answer. We found the equilibrium concentration for T. And we can just kind of just say that that is equal to RK. T is K, same thing. Alrighty, and that's it.